Hello friends, good morning. Coming up with Bayes' theorem on probability. This is very important theorem, and one question from this definitely appears in your plus 2 exam. I am sure if you understand it properly, you are going to come out with flying colors. I am coming up with my notes. Thank you. Hello friends. Before we switch over to Bayes' theorem, let us discuss the following concepts. Number 1, independent events. Number 2, theorem of total probability. These two concepts are a must before we come to discuss Bayes' theorem. I am coming with my notes. Thank you. Hello friends. Let us learn with fun. What are independent events and what are mutually exclusive events? There is a teacher, there is a student. What the teacher is saying, what is the difference between independent and mutually exclusive events? Sir, I know it, and can I explain it on whiteboard? So here is the whiteboard. What he is saying, I is not me is not I. Those events which are independent, they are not mutually exclusive. And those which are mutually exclusive, they are not independent. Events which are not independent are mutually exclusive, and events which are not mutually exclusive are independent. So here are the formulae. Independent events, probability of A when B has occurred is equal to probability of A. B has nothing to do with it. Probability of B when A has already occurred is equal to probability of B. A has nothing to do with it. So this is the formula for independent events. Now let us go to the formula for mutually exclusive events. Nothing is common. It means probability of A intersection B will be equal to 0. So this is the basic difference, and the mnemonic I have told you, I is not me is not I. Events which are independent are not mutually exclusive, and events which are mutually exclusive are not independent. So this is all with fun. Now let us go to theorem of total probability. This is a must before we switch over to Bayes' theorem. Let us try to understand. Number 1, partition of a sample space. This rectangle represents the sample space. E1, E2, E3, and En, so on. They are the mutually exclusive events. Look here, E1, E2, E3, En are n mutually exclusive and exhaustive events. Why I am saying exhaustive? Because the whole sample space has been covered up by them. So S is equal to E1 union E2 union E3 so on union En. So this is sample space. Now theorem of total probability says, if this A is the total probability of these parts. So look here, A is equal to, this is A comprises of, this set is A. This green one with a orange partitions, this is set A. Set A can be written as A intersection E. Look here, A is there, E1 is there. So it is A intersection E1, this is A intersection E2, this is A intersection E3, and so on, A intersection En. So when we unite all this, it becomes A. So probability of A will be probability of A intersection E1. That can be written as probability of E1 into probability of A when E1 has occurred. We are using the conditional probability. Now,
union means plus. Probability of A intersection E2 is equal to probability of E2 into probability of A when E2 has already occurred, and so on. So here EI and EJ, they are mutually exclusive and their intersection will be equal to phi. So this is what the total probability theorem is there. Now let us switch over to Bayes theorem. Here is the Bayes theorem. If E1, E2, E3, En are n non-empty events which constitute the sample space S, look here, this is the sample space S, and E1, E2, E3, En, they are the mutually exclusive events and their union is equal to A. A intersection S is A. This is A and this is S and the common part is this A. So A is equal to A intersection S. Now S we know, S is our E1 union E2 union E3 union En. Now let us substitute here. So the formula will become A is equal to A intersection E1 union A intersection E2 union A intersection so on up to En. So this is the total probability. So let us find the total probability and the formula will become probability of EI when A has occurred is equal to probability of A intersection EI over probability of A, and this is equal to probability of EI into probability of A when EI has already occurred. So now this is probability of EI when A has occurred. Let us substitute this. PA we already know, this is sum of all these events. So probability of A will become probability of A intersection E1, the probability of this, plus probability of this, probability of this, and so on. This will be probability of A. So this is how we will be dealing with the total probability. So this is the Bayes theorem. And this is what I wanted to teach you today. And this theorem is very, very important, and it definitely comes in your final exam. Thank you very much. God bless you. Keep on watching my videos. If you like it, please do subscribe it.